3 weeks ago. You had to draw it, and I made you figure stuff out and do little worksheets. Alright, so then let's just start over. How many degrees are the angles in the triangle add up to? 180 degrees. It's not for you. Well, except for, yes, because you did it, but you don't remember it. So what about a rectangle? How many degrees are in a rectangle? How do you know? Because they're all right angles. Do you need someone in here? Oh, thank you. Because there's 4 right angles, that's true. What if it wasn't? What if it was just another 4-sided figure like this? That's not one. Does it still add up to 360? Because why? Do you remember? Maybe this will jog your memory. That you can figure out the sum of the angles of any polygon by just looking at how many triangles you could draw in it. So, like, you could break this up into 2 triangles. So that's 180 degrees, and that's 180 degrees. Triangle.
Let's see how many triangles.
So if you had a 10-sided figure, you could really just break that up and figure out how many triangles it makes. But you did this little activity before break that apparently you've all forgotten about. That you came up with the formula of how could you relate the number of triangles to the number of sides in the polygon. And it turns out that the number of triangles that you can make of any n-sided figure is always 2 less than the number of sides. And so you can say there's a lovely formula for this that you discovered before break, but forgotten your discovery. That for any n-sided, very important, convex polygon, do you remember the difference between convex and concave? Concave caves in, right? Convex doesn't cave in. That you can take n minus 2, where n is the number of sides, and you can multiply that by 180. And that's because in a 4-sided figure, you can make 2 triangles out of it. In a 10-sided figure, you can draw 8 triangles. No, non-overlapping triangles. So if I had this polygon here, which is a 1, 2, 3, 4, 5-sided, which is also called a 5-sided polygon, pentagon, we could just say, we could take 5 minus 2 times 180, or 3 times 180 would be 540 degrees. And every 5-sided shape has a sum of the integration would be 540 degrees. You better just go get a new paper. He has the paper. He's not down there yet. Okay, so try one. The sum of the angles of a convex nonagon. How many sides does a nonagon have? 9. And then if you get that one done, B, you might need to calculate.
Let's go, paper.
Hey, Brandon Gerke filled out a paper for TA, and then Mr. Gardner just walked in my class and he gave him the paper but to give to you, but then he realized he wrote that Mrs. Dixon asked permission to give Brandon Gerke the answer. Yeah. I know, so I don't know how you do all that. So no rush on it. I just wanted to let you know when you get that Mrs. Dixon's requesting. All right, thanks. Bye. She said, "Oh, that would be." So, who can tell me what I do? Alan, what do I do? I put Chandler in the front row so I can throw things at him. So, okay, what's the formula, Alan? So where do you think that 9 goes to? Yeah, because it's a number of sides. Sure doesn't work, but... Anybody do that yet? 7 times 180. I don't know. Brandon, what do you got? 7 times 180. 1,260 degrees. You should put the degrees. Good. That's not so bad, right? That's a nice formula. What about part B here? What if they gave you this lovely parallelogram and said, find the measure of each interior angle, and they give you all this? Well, luckily, it's a four-sided figure. Do we know what the angles of the four-sided figure add up to? 360, so what can we do, Audrey? Yeah. So we just add them all up. Like, you could be really crazy and write them all out. But plus 4 plus 5x plus 5x plus 11x plus 4 equals 360. Whew. Or Audrey says she just combined the like terms in her head. 5 and 5 is 10x. 11 and 11 is 22 plus 10. 32x. And 4 plus 4 is 8, which is a much nicer equation to use. I like to keep you guessing. Yes, I am. It happens. And so definitely it'd be nice to show me this second equation here at least, so that in case you didn't know, I can see what it is. 252, is that true? 352, I mean, just kidding. Does it work out to be 11? Does that answer the question? Oh, about geometry. It says find the measure of each interior angle. So if x equals 11, don't forget to go back and plug that in. So we would have angle T and angle R both equal 55 degrees. And angle S and angle U are going to be the same. 11 times 11 is, plus 4 is. Could you check that those actually add up to 360? 125 plus 125 plus 55 plus 55, you could actually check your answer there. I liked this section as I was doing the notes, because 1, it was like the same formula over and over again, and 2, I felt like we were doing more algebra than we've done in a while. I heart algebra. A mall is designed so that 5 walkways meet at a food court that is measured in the shape of a regular pentagon. Find the measure of one of the interior angles of the pentagon. Do we have a formula to find the measure of one angle of pentagon?
Yeah, it's called furthers.
Don't talk. Don't talk. Are you gonna roll it back and forth that quick? Are you just using it?
I imagine him going through the hallway to the rolling furthers.
Yeah. I don't really know if that's true, by the way. That's fun. You're gonna go get teachers here.
Also,
Because math and science teachers are in shortage, and those people with the math and science degrees but every teacher, well, you have to teach at a school that's qualified. But every teacher you can get $5,000. But math and science. Pretty exciting game. Chandler, what do I do? Find the measure of one of the interior angles of this regular polygon. Regular pentagon. Oh, how'd you get 540 degrees? We did it earlier. We did 5 minus 2 times 180 was 540 degrees in the pentagon. Now this is a regular pentagon, so what makes that special because it's regular? All the angles are equal, all the sides are equal. So, Chandler, what do I do to find one of those angles if they all add up to 540?
you go that, 40, that.
Right? There's 5 angles, they're all equal, so I'm going to divide by 5. What do you get?
I can calculate it.
No, you don't need a calculator. 5 goes into 5 one time. 5 goes into 4 0 times. 5 goes into 40 8 times.
This
Use your brains.
error.
So that means each one of those equals 180 degrees. So make sure you pay attention whether it's asking for the sum of the angles or just one. Just one, all you got to do is divide it, but it has to be regular to be able to do that. Right? If it wasn't a regular polygon, we wouldn't know how much each one was equal. So, Chandler. I also put Chandler in the front so I can easily just move him up here.
Hey, I will move over there, and then I'll start right after forward.
What about this one? The measure of an interior angle of a regular polygon is 150 degrees. How many sides are in the polygon? Want to just guess and check? Not a good idea.
3, 8.
What's our formula? The only formula we've learned today? N minus 2 times 180 equals the sum of the angles, right? On this one, I'm looking for the number of sides, which means I'm trying to solve for n. Yes?
Yeah.
All I know is one of the angles is 150 degrees. So could I just write 150 equals n minus 2 times 180? Is that correct? What should this equal over here? The sum of all the angles. Do I know how many angles there are? But I know each one equals 150. So what could I write here besides just 150? 4. 5, 8, right? If you add x over here, I just moved the same one. Does that make sense? If there were 5 angles, it would be 150 times 5. If there were 10 angles, it would be 150 times 10. Yes? Once you know how to set it up, it's just solving, just doing the algebra, which hopefully is still there to do. What would I do first? I was telling him in the hallway today, we were talking about, it's January, so that means it's time to talk about Pi Day. It takes a lot of planning to get to Pi Day songs. And I said I was looking up songs over Christmas break, because that's how I spend my Christmas break, is trying to look up Pi Day songs. And I found one that was the Adele song Hello, only it was distribute to the other side instead of hello.
Don't ruin it for us.
That's what made quiet sing it. I sang it in the hallway, and I go, I don't know which one of you guys want to sing it, because it's not me. And they're like, oh, you sounded great.
I sing it.
No, I'm not going to do it, I can't.
You should like us to.
So anyway, the point of that story is we have to distribute. Garrett, what do you get? What do I do? Am I doing what? Subtracting, right? Negative 37, negative 360. I feel like on that little quizzes we did, if some people like to try to do everything in their heads, and if you just write it out, you won't make those little mistakes.
I've heard about it.
Could you check your answer here? You could take 12 minus 2 times 180, then divide by 12 and see if you get 150. Someone do it. I trust you. All right. This is back to your Chromebooks. Let's see how we did before we learn the last thing. Go to Socrative.com. I think I have to go start the quiz though. Socrative, I don't know. And I think I have to start this, but I think you just have to join the quiz. I know. Not really. Oh, they distribute. Hit me. Your face. Do you care if you look here? Socrative, and then you sort of go away. And then I started it, so I think it should come up. Does it come up on yours yet? Okay. There's just 2 questions. Oh, these 2 questions.
What's that? What to do?
I don't need to go back once you hit it. Go back on that. Did you not write it down? No, I didn't. I'm going to start. You need to learn to write it down and not talk at Taylor.
distracting me. Distracting me.
And I even wrote explanations of how to solve them if you get them wrong. Or even if you get it right. I have a lot of effort. A lot of effort. I can see. I put, if you notice when you click your answer, if you got it wrong, I explained how to do it. I even showed my work how to do it. So you should look at that. Okay, wait a minute, I got it up.
I got it right.
Does it give you a note of who you are? Not there. Doesn't mean 598. Okay, I messed up. Waiting on me to do what? Oh. Are my rosters under here? Wait, underneath there, are there rosters? Just skip it. Alright, are we, there's someone that hasn't finished. That's the year. Oh. I know. This is the kind of thing you have to do on your homework, and so it's just like the notes, but you have to make sure if you're finding one interior angle, you use the formula and you divide by the number of sides. Very first chapter we learned about the names of polygons, and so you have to go back and remember heptagon is 7, and then if they give you the measure of the angle, you have to set that up like our last example. So you would, I wrote in the answer there, that 144n equals n minus 2 times 180. Solve that, right? This one was ugly, right? Heptagon is not pretty. Okay? Then one more thing. Yeah, you can sign off, but then just, we'll put them away in a minute. This is my, like, the end of my notes here. Yeah, we're done with it.
Really?
Yes, but don't put it away.
So, you don't sign out. Why not?
I want you to listen. The last thing here is, what about the exterior angles of a polygon? And what's kind of cool, the interior angles differ, right? Like each polygon has a different number of some of the interior angles. But the exterior angles, again, if you have a convex polygon and you look at the exterior angle, which means you have to kind of extend the sides to make an exterior angle. Does that make sense? Like if I just draw a normal, if I just drew a rectangle here, where's the exterior angle? Or you can extend it in either way that you want, right? Like this could be an angle, this could be an angle, this could be an angle, right? It could be like 1, 2, 3, 4. Rectangle's easy. We know a rectangle has 4 right angles, so what would all these exterior angles be? as well. This was a rectangle. What would the angle 1 equal? 90 and angle 2 and angle 3 and angle 4. In every polygon, the sum of the exterior angles, no matter how many there are, will always add up to 360 degrees. So you don't have to have a special formula for each polygon. The sum of the exterior angles, one at each vertex, will equal 360 degrees. So look at that. Welcome to my life. So, these are all exterior angles, yes? So what do we know about all of them together? That's a 360. So we just need to say all of that as a 360. So we could do like I did before. We could write all that out. You want to write all that out? Because it goes all the way around. I think we should just match up, like do Audrey's technique. Let's just add up all the x's. So we did 5x plus 5x plus 4x plus 5x plus 4x plus 6x plus 2x. Did I mess you up?
No.
31. I got 31. Did you get 31? You better check my math. 31x, and then we have to do all the other numbers. I like to do all my positives and all my negatives. So positive 5 and 3 and 3 is 11. Minus 12 would be negative 1. Minus 11. I got minus 12. Did anybody else get that? And what do I set that equal to? 360. So again, if you know that, it's not hard math to do. Who did I forget? It goes by, did you just put them in one spot? $372. Why would I know that? Obviously, that means that I was debating on where to put Wes, and then I moved in, and then I didn't change it. Questions about that? Is that it? Oh, what if I said find the measure of each exterior angle of a regular decagon? Step 1. Decagon is 10-sided figure. So 10-sided figure has how many exterior angles? 10. And what do we know they add up to? And if it's regular, what do we know about each one?
They all equal each other.
So what could I do to find it?
Divide by 10.
Yeah, like you could say, like 10x equals 360. Know that you divide by 10, which means each one would equal 30. I really want us to try to do better at using degree symbols. I'm not going to mark you wrong right now if you don't do them, but it's just good habit to write degree symbols when you can. So, your homework, I make you write it down. I hit it down. 12 through 36 multiples of 3, and then 46, 56, and 57. I think that's only 15 questions. You have some time to work, so I want you to put your Chromebook away, and then I want you to start.